All right, let's take a look at the first page of these notes, solving systems by elimination. Let's see, creating blank blank is one way to use elimination as a strategy for solving systems of equations. I think creating equivalent equations adding or subtracting, that's kind of an easy giveaway there. Equations together that have the same or opposite coefficients. So if they have the same, we're probably subtracting. Opposite coefficients, we would be adding. Will eliminate a variable. You can also blank an equation by a number to make the coefficients, so we can multiply an equation by a number to make the coefficients the same or opposite of each other, so they will eliminate. That is the process of creating equivalent equations. So, as an example, okay, we got things kind of messed around here, but if I took this first equation and I added 2x to both sides, on that first one, I would get an equation that said 2x plus 4y is equal to 4. My second one looks like x plus 5y equals negative 7. Okay, I want to add or subtract equations that have the same or opposite coefficients. These are not that way. If I took the second equation, though, and I multiplied everything there by negative 2, then that second equation, the first one would still be 2x plus 4y equals 4. The second one would be negative 2x minus 10y equals positive 14. And if we add those together now, 4 minus 10 is a negative 6y, and 14 plus 4 is 18. And I can divide by negative 6. And I would get y is negative 3. So that's the y that's negative 3. If I go back up to one of my original equations, I had this one that said x plus 5 times whatever y is equal to negative 7. That gives me x minus 15 is negative 7. If we add 15 to both sides, I get x equals 15 minus 7 is 8. So it looks like my answer is 8 comma negative 3, where this is x comma y. Okay. You can go back into the lessons or something and find another one that we worked out, maybe one that was on a quiz or something like that, to put your own here, and then some notes to yourself that you think you're going to need to remember about this process in order for you to be successful in doing it. Okay. Let's take a look at the back of that first page. Solving systems by substitution tells us substitution is a method for solving systems of equations where a variable is replaced with an equivalent expression. It means we had an equal sign somewhere that said we can make that switch in order to produce a new equation with one variable. Substitution is a more helpful strategy when one variable is already isolated in an equation. That means when it says x equals or y equals, kind of like it does in this one right here. So this one says y is equal to 3x minus 12, which means y and 3x minus 12 are equivalent expressions in this. Equivalent equations take on the whole equals. This says the y and the 3x minus 12 are the same. So wherever we see a y, like this one, instead of y, we can write 3x minus 12. So I've rewritten the first equation, 5x minus 2y equals 15, but where I saw the y, I replaced it with the 3x minus 12. Now, 5x My negative 2 distributes through to a minus 6x plus 24 is equal to 15. 5x's minus 6x's is negative 1x plus 24 is 15. Subtract the 24 from both sides. Negative 1x is equal to negative 9. Divide by negative 1, and x is 9. It's half the job. If x is 9, my second equation, I still need to know what the y is. My second equation said y is 3 times whatever x is, which I now know is 9, minus 12. So that's 27 minus 12, which is 15. So this one has a solution of 9 comma 15. Again, that x comma y combination. And you would be able to go through, pick an example of your own to go through, one that's maybe easier, one maybe that is more difficult, and then think about the things that you need to remember on there for you to be successful doing that. All right, one more to get us caught up. On a graph, the solutions to a system of equations are the points of intersection. If two lines have the same slope and different y-intercepts, they are parallel to each other, then the equations have no solution. If they have the same slope and the same y-intercept, then the equations are equivalent to each other, and there are infinitely many solutions. If they have different slopes, then they have one solution. All right, so let's try these out. The first one is in slope-intercept form. If we think about the lizards climbing the tree, it says this lizard started 4 centimeters below, okay, and then went up half a centimeter for every second. So if we went up half a centimeter and over a second, half a centimeter over a second, half a centimeter over a second, half a centimeter over a second, it looks like those are lining up like that. Okay. So, something like that. This one, I could put it into slope-intercept form, but I'm going to demonstrate some other things. I'm going to try to find intercepts the way that it's put in here. So, to find intercepts is making an xy table once when I make the x0, once when I make the y0. So if I make the x0 in this, the 2 part goes away and I get negative 4y is equal to 12, which would make y equal to negative 3. And if I put 0 in for the y, I get 2x is equal to 12. And so x is 6. So I go out to 6 comma 0. And if I made that line, I really should have, I've got a ruler right here. So here's my first line, a little bit cleaner. Here's my second line. And it looks to me like those lines are parallel to each other. So I would say that there are no solutions. Let me use that. All right. So you can work out an example. Maybe you want to work one out that has infinitely many solutions. Maybe you want to work out one that just has one solution. You've probably got some examples on the previous page that you could use for that you haven't actually graphed. That could be helpful for that. And then, of course, the things that you want to remember that are beyond these things up here in the fill in the blanks. All right.